source called small that's of type plist. So this really means get me the full path, c:\/ or whatever, to small.plist. Now on the iPhone, it's obviously not c:\/ but the same idea. Then what do? Well, then I declare an NSArray pointer, and then I say, give me an NSArray, actually allocate it, and initialize it with the contents of this file. And thankfully, the NSArray class has a method that someone else wrote called initWithContentsOfFile that knows how to do exactly that. You hand it an XML file, or specifically a plist, it will just take care of the rest for you. And voila, you now have an array of the very data that we had in the XML file. And then this line here is doing what? This third and final line. What's the point of this line? Yeah, in back.
It's just basically taking your array that you've generated and sticking it in your somewhere where you can keep track of it.
Perfect. So it's just taking this array that I declared locally with the words pointer, and I'm storing it inside of the object itself by way of the property. So self.words is apparently a property that I defined. And indeed, notice right up here in the same file, I have declared a pointer of type NSArray to words, and I have synthesized it down here. So in other words, this is my way of storing it inside of an instance variable, but doing that with the syntactic sugar of my property. All right, so not to press too hard here, because I know this is kind of a lot and it's a little mundane walking through lots of code. But this is new, what I did up here. I'm still in the M file, and I've put a property inside of my M file. Previously, though, all of our properties were declared where? So in the .h file. So I'm kind of changing what I've been doing up until this point. Does anyone want to propose why, comment might give it away, why I've put the property in the M file now instead of the H file? Yeah?
You want a private property that can't be accessed outside of this.
OK, good. So I want it to be private, as the comment denotes. But specifically, if I want it to be private, that is not accessible by other people, well, other people aren't going to import an M file. What are they going to import with sharp import? Well, an H file, right? And as soon as I put my properties in an H file, that means that I'm advertising to the world, I have this property, feel free to use it, right? That's the implicit implication there. So by relegating my property that only I care about, and no other object in this entire program should care about the fact that I have a pointer to an array of words, better design would say keep things private. Unless you need to expose them publicly, you might as well encapsulate it further inside of your code. Now, this little trick here we mentioned only briefly a couple weeks ago, but when you use @interface in an M file, so recall that we've almost always used @interface in the H file. When you use it in an M file and you put a pair of parentheses afterward that are empty, this is what Apple calls a class extension. This means take the existing interface, add these properties to it, but you can do this now in the M file so that they're effectively hidden. So the rule of thumb here is quite simply, if you're writing a property or even declaring a method that only this class should ever have to call, it's effectively private, don't put it in the H file. Only put in the H file things that you want other classes to know about. Now, I say that this is private property. But the reality is that there really isn't enforcement of a lot of these notions of privacy in iOS. And indeed, a lot of the times when people are taking advantage of undocumented features of iOS, it's because they've somehow figured out that there is a foo method. And the foo method is this magical thing that allows you to tether your phone, for instance, wirelessly to a laptop. Because that functionality is there. It's just Apple's not advertising it in the SDK. So if you pass messages to an Objective-C object and that message is implemented, it will get called, even if you've tried to hide it from other people. So realize this is a design pattern that's a good convention to adhere to so that your partner knows shouldn't call this, so that other programmers know shouldn't call this. But the reality is that adversaries or very creative hackers can figure out that these things exist nonetheless. So it's not so much a security mechanism as it is a design principle, at least in Objective-C. Other languages like Java enforce this much more rigorously. All right. Lastly, I say strong here. So let's try to tease this apart slightly. So previously, when I had an IB outlet, it was weak. Now I've said strong. Why? Any thoughts on what weak and strong are actually doing for me? Okay. Charles?
It's something to do with reference counting.
So it does. It has to do with this feature called reference counting, which Objective-C has underneath the hood and publicly had until last summer when Apple made programming easier for the masses by adding this thing called automatic reference counting, which recalled was that checkbox I checked. So at the risk of oversimplifying for today's purposes, know this. In none of our code yet have we ever called free, or the equivalent of dealloc. We've called alloc, but we never actually free that memory. And this is in stark contrast to C, where anything you mallocked, you then called free on. Well, Objective-C is a little more sophisticated now than C, whereby it keeps track for you of memory that you've allocated. And effectively, when it goes out of scope, it is freed automatically for you. But here's the problem. If you have allocated memory and you don't want it to go out of scope, because some number of seconds or minutes later, you might want to access that same array of words after the user has walked away from the device and comes back. In other words, the method that allocated that array has returned already. You need to tell the compiler, keep this pointer around. Do not let the OS reclaim, thus free, this memory. So by saying strong here for this property, this is sort of planting a stake inside of this object saying, don't let the OS take this away from me. I keep this resident in memory. Whereas weak says, keep it around as long as you like, but I don't really care if it goes away. Now, why the difference then between this and the IB outlet? So just intuitively, it's probably pretty reasonable to expect that if you declare an NS array and its purpose is to store words and you don't want them to go away, strong feels like the right semantics to use, right? Keep this around. As an aside, how is that implemented? Essentially, inside of every object in Objective-C, there's a counter that starts at 1 when it is actually allocated. All right? And then if you go out of scope, that count is decremented to minus one, so you go back down to 0. As soon as an object's reference count is 0, what do you think happens? The operating system frees that memory. It's similar in spirit to garbage collection, familiar with this term, but it's a little better in that garbage collection is often invoked non-deterministically once in a while to reclaim memory. Reference counting, when things go to 0, they're typically immediately reclaimed, which is typically better for performance, at least so far as the user is concerned. If then I allocate this array and it's by default 1, but can very easily go to 0 when it goes out of scope, by specifying strong, what does its reference count actually go to most likely? 2, which means even as it goes out of scope, it does get decremented, but that leaves it at 1, which means I still have a stake in that object, which means the iOS operating system is not going to take it away from me. Now, as an aside, had this course been offered a year ago, you would have had to do all of that +1ing and -1ing yourselves. And this was, I mean, frankly, it wasn't hard once you understand what's going on, but it was prone to lots and lots of buggy code and memory leaks. So in general, a good principle in compilers is assume you're better than the programmer and start to do as much of this for him or her, which is what the OS is now doing. But you still have to provide these hints to the compiler so it knows what's going on. If I did weak, this program could very well crash or just not function, and it might just happen once in a while because of the memory being taken away from me unexpectedly. And now, just as an aside, the reason that you use weak for an IB outlet is because the nib file will take, the nib file is the owner of all of the widgets that you've dragged and dropped there. So it has specified already that its own pointers to those objects will be strong. So you do not need to doubly say, keep these around. You can assume that the nib will do that for you. And indeed, if you specify strong, you might be wasting memory, because if the nib, and this is an oversimplification, if the nib wants to give some memory back to the operating system because that screen is no longer in view because it flipped around, it can't do that if you've specified strong for the text view and the button and all of these other widgets. So your application could end up using more memory than it actually needs to. All right, so that's memory management in a nutshell. But we started with this, the notion of a private property, and the goal was simply to read in these words. So we'll take a break in just a moment. Let's just see which of the methods actually display this data. Because this class, my view controller, is implementing that table view controller now, because I've specified that it's the delegate of a table view, certain messages are going to be passed to it. And among them are just a few of the ones we saw before. Number of sections in table, table view, cell for row at index path, and then down here, if I scroll down ever so slightly further, table view, number of rows in section. So here's how this works. Recall in the nib file, that you have this structure for a table, and it has two outlets, one of which is data source, one of whom is delegate. That just means, again, this thing, this UI widget, will occasionally send messages to the view controller asking for data or informing it that the user has touched something on the screen. Well, what method is it going to call when it wants to know how many rows it needs to make room for? It's going to send the message, table view, number of rows in section, and what do I, the delegate, have to do, or the data source have to do? I just have to answer that question. How many rows do I want? Well, I'm going to do self.words, which gives me my array, pass in the count message. It does what it says. That's going to return 5, or whatever it is, number of words that I have here. So that responds to that question dynamically. Up here, this is asking number